I wanted to just take a second to clarify some things regarding our discussion of the safe minimum standard, both conceptually what it is, as well as to give some examples to flesh out that rectangular diagram that we had that I had showed last class. So if you remember that diagram, we had a rectangle which represented actions we could take, which would result in some amount of environmental damage or natural resource degradation, which would have some level of severity associated with it, as well as some level of irreversibility associated with it. And so on the horizontal axis, this is measuring the degree of irreversibility. So as we move from right to left, we are engaging in activities that result in more irreversible kinds of actions, things that have more irreversible effects on the natural environment. And as we move from the bottom to the top, we are taking on actions which have a more severe impact on the natural environment or on the natural resources. And those are two separate things. The severity is somewhat different, somewhat distinct from the irreversibility, and we can represent the combination of severity and irreversibility as any point inside of this rectangle. And we said that a safe minimum standard is essentially a line, a bright red line, dividing up or separating these different regions of things that have a particular combination of severity and irreversibility, separating that space into things where we are going to allow economic trade-offs to occur, where we're going to allow substitution of man-made capital for natural capital. So that's this region here where we're things that are to the right and below this red line. In terms of irreversibility and severity, we are going to let man-made capital substitute for natural capital. But everything to the left and above this red line, we're going to completely rule out making economic trade-offs. We're not going to let that resource degradation occur, regardless of what the human benefits could be, regardless of what we might gain in terms of consumption or human capital or physical capital. We're not going to let those resources be degraded to that level of severity and with that amount of irreversibility, regardless of what other kinds of economic benefits could result. And I wanted to specifically give some examples of types of pollution or types of damages, ecological damages, natural resource damages, or human damages that would fall in different regions of this space, just to kind of put some concrete concepts or events into different regions of this space. So in terms of things that are on the lower right-hand area of this graph, things that are not very severe and also very irreversible, those could be things like light pollution or noise pollution. Those kinds of pollution you're able to reverse them very quickly. So the noise pollution ends as soon as the noisy activity stops. There's no persistence. Same thing with the light. Once you turn off the light, there's no more persistence of that light in the air or in the environment. And I guess it's debatable how severe that is, but I kind of imagine that as being kind of near the bottom in terms of types of pollution that are severe. So those kinds of pollution you can think of being in the lower right-hand corner of this space. Another type of pollution, which might be, you can think of it as kind of a little bit more reversible and perhaps more severe than light pollution or noise pollution, would be just local air pollution. This would consist of things like sulfur dioxide and nitrous oxide, which accumulate and perhaps linger over urban areas, and they cause respiratory irritation and eye irritation and throat irritation for people that are breathing that air. And that has some potentially very serious health effects, and would also kind of would go away. The air would kind of dissipate after a while. New air would kind of flow in to that area and blow away the pollution, and so it doesn't persist in the same way that other kinds of pollution would. So that would be an example of something that's a little bit more severe, but still kind of in the area of the space of reversible kinds of damages. A type of pollution that might be roughly as severe as local air pollution, but perhaps less reversible, would be nutrient pollution. In fact, it might not be as severe as local air pollution because nutrient pollution doesn't affect directly people's health as much as local air pollution. So we might even bump that down a little bit relative to local air pollution. But nutrient pollution is something that persists a little bit more in the environment. Nutrients like nitrogen and phosphorus run off agricultural fields and come out of wastewater treatment plants and end up in lakes and streams and bays. And it produces rapid growth of algae, which after the algae die, it eats up oxygen in the water and it causes a lot of both toxic chemicals that are given off by the algae itself, as well as eating up oxygen in the water, which ends up killing a lot of fish and just destroying the aquatic environment. So that's an example of something that's moderately severe, potentially very severe if it gets out of hand, but it's less reversible than local air pollution because those nutrients actually persist in the environment a lot longer, and there's actually feedback processes which make it very difficult to reverse the effects of that nutrient pollution even after you stop discharging nitrogen and phosphorus into that aquatic environment. An example of something that might be not reversible but very severe. It's not exactly a kind of pollution, and I don't know if there's actually a specific kinds of environmental issue that falls in this upper right category, but the best thing I can think of would be just something like a really severe storm, something like a hurricane or a tornado or something like that, which if it was the case that we were directly responsible for causing that particular storm, that would be something that could be extremely severe. It could cause a lot of damage, especially if a hurricane hits a city. There's a lot of physical infrastructure and potentially people's lives that are destroyed. But once the storm blows through, it doesn't cause persistent damage after that, other than the fact that you have to maybe rebuild the physical infrastructure. But it tends to be the case that the destruction of physical infrastructure is not a serious, persistent, long-term problem. There's a lot of rapid recovery that can occur if the only thing that needs to happen is building the physical buildings back up. That's a relatively easy thing to do, and it doesn't have very long-term impacts, and economies tend to bounce back very quickly from shocks like storms like that. And then an example of some kind of environmental impact that might be not that severe but irreversible would be the case where maybe one species of bird goes extinct, right? So that would be an irreversible event. That genetic material will be lost. The bird will not be able to pass on that genetic material onto its offspring, and so that bird species will be lost. But it's not going to have an enormous impact on the ecosystem as a whole. Some particular individual birders might be sad to see that bird species lost, but it's not, the scale of the impact on kind of a global level is not going to be extremely severe. An example of that, which would be irreversible and more severe, would be if, say, thousands of species of birds and other mammals and plants go extinct. At that point, potentially you're talking about disrupting entire ecosystems and kind of the balance of the flow of energy and materials through an environment, which could have a lot of spillover effects and in fact even just directly reduce the overall quality of the environment, the desirability of going out into the outdoors and being able to enjoy those wildlife. That would be lost, and because it's on a much larger scale than now that you're talking about thousands of species going extinct, that's something that's just as reversible as the one bird species, but potentially more severe. And then the upper left quadrant, where we have extremely severe events that are also potentially irreversible. This would be something like maybe a particular atmospheric or ocean current gets reversed, and it totally makes certain areas of the world uninhabitable. That's something that would be extremely difficult to reverse. Those are sort of global patterns that humans don't have a ton of direct ability to influence, or at least reverse the influence after they've maybe produce some kind of climate change that causes the change in the first place. It's very difficult to take that back and push the air and make it go in a different direction. That's not easy to do. And it could also be extremely severe in terms of the ways that it affects the temperature and the rainfall and the water levels in different areas of the world that affect how well humans can exist in that climate or in that habitat. So let me put light and noise pollution back in this diagram. And this is just a kind of a list of some examples of different kinds of pollution or environmental impacts that could fall in different regions of this two-dimensional space with severity on one axis, irreversibility on the other axis. So hopefully that makes the discussion of safe minimum standard a little bit more concrete. And again, you can think about that safe minimum standard as being a line that you draw through this space in some way to prohibit trade-offs in certain regions of this space, prohibiting things that are of a certain severity and irreversibility, but allowing economic trade-offs in other regions. And the safe minimum standard is the choice of that safe minimum standard is a choice of where to place that line in this space of different potential environmental outcomes.